You can see here in the previous class we discussed when resistor is there at t equal to 0 plus and t equal to infinite. This is initial condition and this is at steady state. This is before switch on. When the switch is open, when it is resistor, after switch on or at steady state, it acts as resistor only. Inductor, if before switching on no current flows, after switching on initial condition also no current flows, at the steady state it acts as short circuit because initial condition open circuit, steady state short circuit. Similarly, capacitor, before switch on, if no voltage is present, it acts as short circuit after switch on also, and then at a steady state it will act as open circuit, which means sudden changes in current are not allowed by inductor, sudden changes in voltage are not allowed by capacitor. If you see before switch on, if there is some current flowing in the inductor, same current flows after switch on, which is called initial condition, and at the steady state t approaches infinite, at t equal to infinite, it will be short circuit with a parallel branch of the same current I0. So before switch on, after switch on, current I0 flows in the inductor. Now, if there is a capacitor, before switch on, if voltage V0 exists, after switch on, initial condition also voltage, same voltage V0 exists, and at t equal to infinite steady state, the same voltage along with open circuit will work. If you observe the capacitor, before switch on no voltage, after switch on no voltage. Before switch on, if V0 is the voltage, after switch on also V0 is the voltage. Sudden changes in voltages are not allowed by capacitor. In inductor, if no current before switch on, after switch on also no current. Before switch on, if I0 is the current, after switch on also I0 is the current, which means sudden changes in current are not allowed by inductor. Okay, these are the main 2 points we will remember. Based on this one problem yesterday we have completed. One problem we have completed this, calculated current I and the first order derivative of I and the second order derivative of I at t equal to 0 plus means after switch is getting on. Now I am going to the next problem. Next problem in the same DC transients. Next problem. You can see here there is a circuit. There is a circuit. Two loops are present. Two loops are present. We have to find the switch is closed at t equal to 0. Switch is closed at t equal to 0 and find the values of I1, I2, di1 by dt, di2 by dt, d square I1 by dt square, d2 d square I2 by dt square at t equal to 0 plus. Okay. Now I will proceed. Two loops are there, two currents are flowing. Okay. And now I will go with the solution. I will go with the solution at t equal to 0 minus. At t equal to 0 minus. Switch is open. Okay. Switch is open. When switch open, what happens? I1 current does not exist. I1 of 0 minus does not exist. Okay. There is no supply in the, here if you see, we need not bother about current in the first loop because it leads to confusion. I will go with the capacitor in the first loop because voltage in the capacitor in the first loop, capacitor is present, second loop, inductor is present. Okay. So at t equal to 0 minus, switch is open. This is our case when switch is open. This is our situation. Now capacitor. In capacitor, Vc of 0 minus is 0. No voltage is produced. If current travels, then only some voltage is developed. No voltage is produced at 0 minus. Similarly, in the second loop, there is a inductor. So current in the inductor also 0 because there is no supply in the second loop. These are the condition at t equal to 0 minus. Okay. And hence, at 0 plus, when switch is closed, at t equal to 0 plus, switch is closed. When switch is closed, sudden changes in current not allowed by inductor, sudden changes in voltage not allowed by capacitor. Okay. So same Vc of 0 plus also 0 and I2 of 0 plus also 0. The reason is sudden changes in voltage not allowed by capacitor. Not allowed by capacitor. The second one, sudden changes in current, okay, not allowed by inductor. Not allowed by inductor. So with this, we have completed a little portion. Now we will see with the next analysis, voltage and current respectively, we completed voltage and current, voltage in capacitor and current in inductor only, our main concept. Now, when switch is closed, okay, we will analyze the circuit. Switch is closed, what happens to the circuit? If I redraw the circuit, this is the DC supply, then here switch is getting closed, okay, here, yes, switch is getting closed, and then we have a capacitor which is acting as short circuit, okay. So here capacitor is present which is acting as short circuit because sudden changes in voltage not allowed. And then we have the resistor 10 ohms and another 10 ohms, and then, okay, inductor, there is no current flow. Inductor, there is no current flow. So here in the place of inductor, we have to put open circuit. This is inductor, we are putting open circuit. This is 10 ohms resistor, 10 ohms resistor. Understood what is done? So we are bothered only about capacitor and inductor. In the place of capacitor, I have put short circuit. In the place of inductor, I have put open circuit. Why? It is VC of 0 plus equal to 0. That's why short circuit. I2 of 0 plus is 0. That's why open circuit. Okay. But still, we have we have a closed loop in the first mesh. We have a closed loop in the first mesh. I1 current is there. We are not bothered about I2. We are not bothered about I2 because there is open circuit. I2 0, we concluded. Okay. Now we will calculate what is I1 value at 0 plus. I1 value at 0 plus. Now the supply voltage 10 volts divided by, it is a closed path, 10 ohms resistor alone is present. Okay. And this is 1 ampere current. I1 of 0 plus is 1 ampere current. Okay. And we already know, okay, we know I2 of 0 plus is 0, we concluded. And then VC of 0 plus is 0, we concluded. Okay. These things we analyzed at a switch is closed. Now we will go with the KVL equation in the closed loop KVL equation. Okay. So now I am going with KVL for loop 1. I will proceed with this equation. I will proceed with this equation. Okay. Now what I will do, I can make di2 by dt as subject. L I will retain plus 20 times I2 minus 10 times I1 equal to 0. Then if I take di2 by dt as subject, okay, di2 by dt as subject, it becomes, what is L value? You can see here L value is 1 Henry. Okay, L value is 1 Henry. So 20 by 1, 20 by 1 I2 minus 10 by 1 I1 equal to 0. If I make di2 by dt as subject, okay, what happens? This is 10 times I1 minus 20 times I2. If I make di2 by dt at 0 plus, this becomes 10 times I1 at 0 plus minus 20 times I2 at 0 plus. Okay. Now what happens? I am calculating di2 by dt at 0 plus equal to 10 times I1 of 0 plus, you know the answer, it is 1 ampere. I2 of 0 plus, it is 0. Okay. I2 of 0 plus, it is 0. 10 into 1 minus 20 into 0. Now what happens? This is di2 by dt at 0 plus, it is equal to 10 ampere per second. 10 ampere per second. Okay. So I have tried the equation. Okay. Loop 2 completed. Right side thing I copied as it is. Loop 2 completed. Now I am going with loop 1. I will take another color. So KVL for loop 1. KVL for loop 1. Okay. So you can see loop 1 voltage. You see the circuit, whichever circuit, original circuit, after switch is closed. After switch is closed, okay, everything is present. After switch is closed, we have just written at t equal to infinite, we are writing the equations. Okay. So what we are writing the equations is at t equal to infinite. So all the inductor and capacitor will be present. Okay. So KVL for loop 1 also we are writing at t equal to infinite. So what will happen in the first loop? You will have the supply voltage. You will have the supply voltage. Then capacitor will be present. Here resistor will be present. Resistor will be present. And inductor will be present. Okay. Inductor value is 1 Henry. Inductor value 1 Henry. And capacitor value 2 microfarads. 2 microfarads. Supply voltage 10. And then both the resistances are 10 ohms. Okay. Supply voltage 10. Both the resistances are 10 ohms, 10 ohms. And now this is at t equal to infinite. Circuit KVL equations we are writing for t equal to infinite. Okay. So I1 current and I2 current are present. Now for loop 2 I have completed. Left side loop 2 I have completed. Now KVL for loop 1 I am going to write. So loop 1 we have supply voltage equal to 1 by C. Okay. Integration I1 dt plus 10 ohms is present. Two currents are flowing. So I1 minus I2. I1 minus I2. This be equation number 1. This be equation number 1. Okay, if you differentiate this, what happens? If you differentiate this equation, what happens? Differentiate. So it will become 0 equal to 1 by C, integration differentiation gets cancelled, plus 10 times, okay, this is I1 current, d I1 by dt minus d I2 by dt. Okay, now I have to make d I1 by dt as subject. So 10 times di1 by dt equal to I1 by C minus 10 times di2 by dt. Okay. Now this 10 I will send to right side. di1 by dt, which is nothing but I1 by R value is 10. Okay. So C value 2 microfarads. 2 microfarads minus 10 by 10 will become 1. Okay. So di2 by dt. The left side 10 I am sending to right side. Now I will calculate this entire thing at 0 plus. I will calculate the entire thing at 0 plus. So I1 of 0 plus I have to take here, and 10 into 2 is 20. Okay, 10 into 2 is 20 into 10 power minus 6. Micro means 10 power minus 6 minus 1 into di2 by dt at 0 plus I have to use. Okay, so let this be equation number 3. Equation number 3, and let this be equation number 4. Now I am using 3 in 4. Okay, use 3 in equation 4. Now what happens? di1 by dt at 0 plus equal to 1 by 20 micro. So what I will do? 1 by 20 into 10 power plus 5 I will take, and then I1 of 0 plus, you know, here 1 ampere. Okay, so I1 of 0 plus, it is 1 ampere minus 1 into, okay, di2 by dt at 0 plus, it is 10 ampere per second minus 10. You can simplify this. Okay, you can simplify this. What happens? I will take 100 by 20 into 10 power 3 minus 10. Okay, so 5 into 10 power 3, 5000 minus 10, which becomes 4990 units are ampere per second. Okay, so this is about, I will take this final answer as something equation number 5. The final answer I am taking equation number 5, and that equation 5 LHS, what is that LHS? di1 by dt at 0 plus. Okay, di1 by dt at 0 plus, the value is 4990 ampere per second. You see our question, you should calculate the first order derivative, second order derivative also at 0 plus. Second order derivative also at 0 plus. Okay, so what is the next thing? Equation 1 and 2 you differentiate one more time. Equation 1 and 2 you differentiate one more time. Okay, so what happens? Right side, I need second order derivative, no? So I will make this as equation 1a. Equation 1a and 2 I will differentiate one more time. Okay, whatever you want you can do. This is the simplified version. This is the simplified version 2a. So 1a, 2a, if I differentiate, it will be easy for me. Okay, now differentiating equation 1a. Differentiate equation 1a. Now you see what is equation 1a. 10 times di by dt is there. My cursor is visible, I think. Equation 1a you see here, I am going to differentiate one more time. Okay, so or this you can make equation 1a rather than the previous line. Next line, if you make equation 1a, is little bit easy. I'm making the next line as equation 1a. I will differentiate this one. I will differentiate this equation 1a. Okay, now di1 by dt is there. So differentiating it will become d square I1 by dt square. Okay, then right side I1 by 10 into 2 micro is there. So 1 by 20 micro I will retain, and di1 by dt it will become. I1 if you differentiate, di1 by dt it will become. Okay, so minus 1 into di2 by dt is there. So minus 1 into d square I2 by dt square. Okay, let this be equation 1b. 1a has become 1b. Okay, so just to remember, I am giving equation numbers like that. 1a has become 1b. Now I will go with 2a and differentiate. Okay, I will take 2a equation and differentiate. So 2a equation is di2 by dt. So if I differentiate 2a equation, you see 2a equation left side di2 by dt will become d square I2 by dt square. Okay, next RHS 10 I1 is there, so it will become 10 times d, it is I1, so d I1 by dt. Okay, next minus 20 times I2 is there, so it will become minus 20 times di2 by dt. Okay, this will become 2b, equation 2b. So 2a became 2b. Now if you see already, it is easy to calculate equation 2b first. Okay, 2b first. So using, what are the values you will use? Equation 3 and 5. Equation 3 and 5 I will substitute in 2b. Okay, use equation 3 and 5 in 2b. In 2b, what happens? D square I2 by dt square I am going to calculate at 0 plus. 0 plus. So d I1 by dt at 0 plus minus 20 times di2 by dt at 0 plus. Okay, so this we already calculated. I1 by dt, di1 by dt at 0 plus, right side 4990. Okay, it is plus or minus? So plus only, 4990. 4990 minus, now equation 3 you can see. Equation 3, it is also positive, 10 ampere per second. Okay, minus 20 into 10 ampere per second. Now what happens? This is 49900 minus 200. Minus 200. This is the value. How much is this now? 49700. Units are ampere per second square. LHS, it is d square I2, okay, by dt square at 0 plus. D square I2 by dt square at 0 plus. Okay, now let me make this as equation 5 completed. Now I will use this as equation 6. Okay, now use 5 and 6. Now use 5 and 6 in equation 1b. Use equation 5 and 6 in 1b. What happens? D square I1 by dt square at 0 plus equal to 1 by 20 micro d I1 by dt at 0 plus minus d square I2 by dt square at 0 plus. Okay, this becomes 1 by 20 micro, and what is this value from equation 5? It is 4990. This is 4990. Okay, minus this value from 6, it is 49700. And now this is 10 power 6 by 20, and then 4990 minus 49700. Now if you see how we can proceed about it, this becomes 100 by 10 power 4. Okay, 100 by 20 is 5 into 4990 minus 49700. Okay, this is a bigger value. This is a bigger value. If I take 10 power 4 common in both of this, 10 power 4 common, this becomes 0, 45, 4, 49, 4, 24. Okay, minus 10 power 4 common, this is 4.97. 4.97. So finally it becomes approximately 5 if you remove 2, 4, 9, 45 into 10 power 4. Okay, ampere per second square. This is the final answer, which is d square I1 by dt square at 0 plus. Okay, d square I1 by dt square at 0 plus. This is the last answer, equation number 7. Okay, so our answers are, you see the question, I1, I2 simply at t equal to 0 plus, first order derivative and second order derivative. Okay, I1 and I2 here itself we have concluded in the first slide. I1 at 0 plus 1 ampere, I2 at 0 plus is 0. First order derivative is equation 3 and 5, we got the answer. Second order derivative equation 6 and 7, we got the answer. Okay, so this is about DC transients for the given problem.